Okay, so for our next example, example number 5, now that we're experts and we know how to transform our functions, we're going to try it with a very special number. And that special number that we're talking about is E. E is Euler's number, and it is like pi in the fact that it's an irrational number. Now, an irrational number is just a number that the decimal goes on forever and never repeats, and it never terminates. In fact, this number will just go on and on and on and on and on forever. Now, where this number comes from is Euler was sitting around one day and he said, I want to think of a number, and that number's value is based on the limit of the following function. 1 plus 1 over x raised to the x. And you may not realize this, but that's like a rate of change type problem, like a percentage rate, right? So this is almost identical to a formula that we would use for like a car payment or your house note or anything that requires interest, a percentage, or growth. And so what he said is, I want to figure out what this particular function would be as x approaches infinity. And to kind of verify that, I'm going to pull up the calculator and we'll plug it in. And so if I say 1 plus, oops, I got to start that with parentheses. Oops. 1 plus, and then parentheses again, 1 divided by x, close the parentheses, raised to the x, and I hit clear, and I graph that. That's what the graph looks like. And so what Euler did is he did some pretty fancy math, and I don't have time to go through all that stuff today. We'll learn about that in calculus next year. But what he did is he just started plugging in a bunch of values for x. And so like if you plug in a really big value for x, notice that the y value, the corresponding y value is 2.59. So if I keep going in the x direction, the y value keeps going and keeps going and keeps going and keeps going. And eventually it will reach that 2.71. And it doesn't go any further. So see how this line kind of tapers off? Well, it never really gets bigger than this number here. Okay? Now, we like this number because E has some unique qualities. And so for example number 5, we're going to study the behavior of these functions. So consider the function y equals e raised to the 2x. Well, e to the x, if I graph e to the x, it looks completely different. This is how e is found, but e to the x is done a little differently. So if I clear this, and on your calculator, see where your pi number is in blue? E is the divide sign, but it's in blue. So I hit second divide, and that pulls up my e, and then we raise it to the x. And if I graph it, this is what the graph looks like. And it's just a regular exponential. It would be almost the same as if I put in 2.72 and then raise that to the x. So remember that e is a number when we use it in our calculator. So now what would happen by putting that 2 in front of the x? What do you guys think would happen? It stretches it. And the reason for that is whatever value I put in for x, right, it's going to double it. Does that make sense? So when we look over here, when we look at these values, the blue values are just e to the x, but now look at the corresponding y values. it's still the same values, but it grows a lot quicker. In other words, right here, when x equals 1, my y value, or when x equals 2, my y value is 7.3. Here it is 7.38 when x equals 1. Here, I've got, when x equals 4 on the original function, I've got a y value of 54. While when x equals 2, for the second function, I get that same value because 2 times 2 is 4, right? So they both mean the same thing. All right? What do you think happens when I graph e to the negative x? By the way, you guys should be writing this down. I know you guys are awed by me teaching you, but make sure that you're writing all this down. These are part of your notes. What's going to happen when I change that to e to the negative x? Can somebody tell me while I'm entering it in my calculator? It'll reflect over the y? Yep, that's exactly what it'll do. Because when I plug in a negative x value, that extra negative sign will make it positive. When I plug in a positive x value for my input, that negative sign will change it to a negative value. So that it's going to flip it across the y-axis. Okay? What do you think is going to happen when I graph 3e to the x? What's the 3 going to do? Stretch it vertically or horizontally? It's vertically. It kind of looks horizontally. I mean, you could say horizontally, and that's how it would look, right? But technically, it's stretching it horizontally. So let's go in there and try that. So I'm going to just insert a 3, and we'll just do x. 3 e to the x. So it's going to have similar behavior, but it's going to take the y values and just multiply them by 3. Now what that means is, whatever this y value is, when I multiply it by 3, I get this. Whatever this is, I multiply it by 3 and I get this. Does that make sense? Technically. It's a little different because let me think that through. It's not quite multiplying it by 3, is it? You're multiplying e to whatever that number is by 3. So I guess what I'm saying is like 7.38 times 3 is 21, right? But then I get 163 here. So what did Mr. Adams pick up on? What did he catch? Did you guys see what I did? I entered it in the calculator wrong and it gave me the wrong answer. Because I noticed that 7.38 times 3 wasn't 163. It's actually more like 22.163. Still vertically stretches it, just not as much. That's why it's so important to know all these different things, because you can make a simple mistake like Mr. Adams did and still get the wrong answer on the calculator. And you really need to know and think about it, because that's how you double check and make sure you have the right answer. It's a good test-taking strategy. With that being said, are there any questions about this particular one? No?